The specification 75 UV per lambda is incorrect and meaningless. Ultraviolet output is typically measured in microwatts per lumen or percent ultraviolet. Standard F32T8 fluorescent lamps typically have the following ultraviolet output. For ultraviolet A, which is 315 to 400 nanometers, the output is 0.7 to 1.7 microwatts per lumen. For ultraviolet B, which is 280 to 315 nanometers, the output is negligible, less than 0.5 microwatts per lumen. This means that an F32T8 lamp with a lumen output of 3200 lumens would emit approximately 2.24 to 5.44 microwatts of ultraviolet and negligible ultraviolet B. You can find the ultraviolet output information for specific lamps in the following places. Firstly, lamp manufacturers' datasheets. Look for sections on optical characteristics or radiation output. Secondly, lighting standards websites. Organizations like the Illuminating Engineering Society and the International Commission on Illumination publish standards and guidelines that include information on lamp ultraviolet output. Thirdly, third-party testing laboratories. Independent laboratories can measure the ultraviolet output of lamps and provide certified reports. To address the owner's request, you should firstly clarify the incorrect specification. Explain that the specification provided 75 UV per lambda is incorrect and doesn't correspond to any known ultraviolet measurement unit. Secondly, provide lamp data. Send the owner the lamp data, including the ultraviolet output information, and explain how this information relates to the owner's requirements. If the owner is concerned about ultraviolet exposure, discuss possible mitigation strategies, such as using ultraviolet filters or limiting exposure time. When evaluating the ultraviolet output of lamps, it's important to understand the different types of ultraviolet radiation. Ultraviolet A, ultraviolet B, and ultraviolet C each have different wavelengths and potential effects. Ultraviolet A has the longest wavelength and is the most common type of ultraviolet radiation. Ultraviolet B has a shorter wavelength and is more harmful than ultraviolet A. Ultraviolet C has the shortest wavelength and is the most harmful, but it is mostly absorbed by the atmosphere. The ultraviolet output of a lamp can be affected by several factors, including the lamp's design, the materials used in its construction, and the operating conditions. It's important to choose lamps that have been tested and certified to meet industry standards for ultraviolet output. When choosing lamps for an archives project, it's important to consider the potential effects of ultraviolet radiation on the materials being stored. Ultraviolet radiation can cause fading, discoloration, and other damage to paper, textiles, and other organic materials. To minimize the risk of ultraviolet damage, it's important to choose lamps with low ultraviolet output and to use ultraviolet filters to block any remaining ultraviolet radiation. In addition to choosing the right lamps, it's also important to control the amount of light that enters the archives. Natural light can be a significant source of ultraviolet radiation, so it's important to block sunlight with curtains, blinds, or other window coverings. The duration of exposure to ultraviolet radiation is also a factor in the amount of damage that occurs. The longer the exposure, the greater the damage. Therefore, it's important to limit the amount of time that materials are exposed to light. By taking these steps, you can minimize the risk of ultraviolet damage to the materials in your archives. Always consult with a lighting professional to ensure that you are using the appropriate lamps and lighting controls for your specific application. The Illuminating Engineering Society, also known as IES, provides comprehensive guidelines on lighting for various applications, including archives. These guidelines include recommendations for ultraviolet output levels, color rendering, and other factors that can affect the preservation of materials. The International Commission on Illumination, also known as CIE, is another organization that provides standards and guidelines for lighting. CIE standards cover a wide range of topics, including ultraviolet radiation, color imagery, and photometry. Third-party testing laboratories can provide certified reports on the ultraviolet output of lamps. These reports can be used to verify that lamps meet industry standards and to compare the ultraviolet output of different lamps. When addressing the owner's request, it's important to communicate clearly and effectively. Explain the difference between microwatts per lumen and percent ultraviolet, and provide data on the ultraviolet output of the lamps you are considering. Be prepared to answer questions about the potential effects of ultraviolet radiation on the materials in the archives, and explain the steps you are taking to minimize the risk of damage. If the owner is still concerned about ultraviolet exposure, you can suggest additional mitigation strategies, such as using ultraviolet-absorbing films on windows or installing ultraviolet monitoring equipment. It's also important to consider the cost of different lighting options. Though ultraviolet lamps and ultraviolet filters can be more expensive than standard lamps, but they can provide significant protection for the materials in your archives. Ultimately, the decision of which lighting system to use will depend on the owner's budget, the sensitivity of the materials being stored, and the level of risk that the owner is willing to accept. In conclusion, understanding the ultraviolet output of lamps is essential for designing a lighting system for an archives project. By choosing low ultraviolet lamps, using ultraviolet filters, and controlling the amount of light that enters the archives, you can minimize the risk of ultraviolet damage to the materials being stored. Always consult with a lighting professional to ensure that you are using the appropriate lighting system for your specific application. Remember to clarify any incorrect specifications, provide accurate lamp data, and discuss mitigation strategies with the owner to ensure that their concerns are addressed. By following these steps, you can create a safe and effective lighting environment for your archives. When presenting the ultraviolet data to the owner, it's helpful to provide context and explain the potential implications. For example, you could explain that the ultraviolet output of standard F32T8 lamps is relatively low compared to other sources of ultraviolet radiation such as sunlight. You could also explain that the materials being stored in the archives are likely to be sensitive to ultraviolet radiation and that it's important to take steps to minimize exposure. In addition to providing data on the ultraviolet output of the lamps, it's also important to provide information on the spectral power distribution of the light. The spectral power distribution describes the amount of light emitted at different wavelengths. This information can be used to assess the potential for damage to different types of materials. For example, some materials are more sensitive to ultraviolet radiation at certain wavelengths than others. By understanding the spectral power distribution of the light, you can choose lamps that minimize the risk of damage to the specific materials being stored. When discussing mitigation strategies, it's important to consider the cost and effectiveness of different options. Ultraviolet filters can be effective at blocking ultraviolet radiation, but they can also reduce the amount of visible light that is transmitted. This can make it more difficult to see the materials being stored. Ultraviolet absorbing films can be applied to windows to block ultraviolet radiation from sunlight. These films can be effective at reducing ultraviolet exposure, but they can also be expensive to install. Limiting exposure time is another way to reduce the risk of ultraviolet damage. This can be achieved by rotating materials, using light blocking covers, or reducing the amount of time that lights are turned on. Ultimately, the best mitigation strategy will depend on the specific circumstances of the archives project. It's important to weigh the cost and effectiveness of different options and to choose the strategy that provides the best balance between protection and visibility. When selecting lamps, it's also important to consider the color rendering index, or CRI. The color rendering index is a measure of how accurately a light source renders colors. A higher CRI indicates that colors will appear more natural and accurate. For archives projects, it's important to choose lamps with a high CRI to ensure that the materials being stored can be accurately viewed. In addition to the color rendering index, it's also important to consider the color temperature of the light. The color temperature is a measure of the warmth or coolness of the light. Lower color temperatures produce warmer, more yellow light, while higher color temperatures produce cooler, more blue light. For archives projects, it's generally recommended to use lamps with a color temperature in the range of 3000 to 4000 Kelvin. This range provides a good balance between color rendering and visual comfort. Finally, it's important to consider the energy efficiency of the lamps. Energy-efficient lamps can save money on electricity bills and reduce the environmental impact of the archives project. Light-emitting diode, also known as LED, lamps are generally more energy efficient than fluorescent lamps. When choosing LED lamps, it's important to look for lamps that have been tested and certified to meet industry standards for energy efficiency. By considering all of these factors, you can choose lamps that provide the best balance between ultraviolet protection, color rendering, energy efficiency, and cost. Always consult with a lighting professional to ensure that you are using the appropriate lamps and lighting controls for your specific application. Remember to stay informed about the latest advances in lighting technology. New lamps and lighting controls are constantly being developed, and these new technologies may offer improved performance or energy efficiency. By staying up to date on the latest trends, you can ensure that your archives project is using the most effective and efficient lighting system possible. Consider the long-term maintenance of the lighting system. How easy is it to replace the lamps? Are there any special disposal requirements for the lamps? By considering these factors, you can minimize the long-term costs of operating the lighting system. Regularly inspect the lighting system to ensure that it is operating properly. Look for any signs of damage or wear and tear. Replace any damaged or worn parts promptly. Regularly clean the lamps and fixtures to remove dust and dirt. This will help to maintain the light output of the system and prevent damage to the lamps. The goal is to preserve the integrity of historical documents and artifacts, which requires a delicate balance between illumination and protection.